Okay, chemistry students, this is my first screencast, so you have to bear with me as it's hard to write on the little board I'm using. So it'll be even worse than normal, but you all can handle it. First of all, you know that you have to laugh at my joke here on 3. Ready? 1, 2, 3. Hope it got a lot of laughter. Do you get it? Iron, Ferris. Hopefully you get it. I know Trevor did in second period. Okay, so today we're going to talk about balancing chemical reactions. This is something you all already know a little bit about and we've been working toward, but we're going to talk about how to actually balance them. First of all, you have to know how to convert a sentence that is in chemical formula to one that has words. And what I mean by that is this first one has these little S's, L's, and AQs. You already know what they mean, and we know this one means solid, liquid. AQ means aqueous. Hopefully you remember what that means. It means in a solution with water. And gas. So to write this out, we would say solid. My writing's going to be horrible on this. Sodium. Whoa. Sodium. I should probably just type. Let's see here if I can make that happen. Alright, we're going to say solid, sodium, and liquid. You can use common names when you're doing this, so we'll say water. What does an arrow mean? It means either yields or produces. Aqueous, so in solution. Sodium hydroxide. That is our polyatomic ion, sodium hydroxide. Make this a little smaller. And hydrogen gas. Now you wouldn't be wrong if you said gaseous hydrogen, but hydrogen gas just sounds better. It's all about what sounds good. But as long as you're right, that's okay. If you could pause it right here and try this next one yourself. Alright, so let's try this one. You should have gotten solid, iron, and oxygen gas yields, oh my gosh, iron, don't forget the charge. The charge here is 3 oxide. Oh, but I forgot something. It needs to say yields solid iron 3 oxide. How did I figure out the charge? Hopefully you remember that what you have to do is uncross it here and you're going to get a 3. Uncross it here and get a 2. Does oxygen normally carry a charge of 2? It does. So there you go. Alright, let's see here. Practice another one. Going the opposite direction. So I'm given the sentence and I have to turn it into an actual chemical formula. This time I'm going to have to write messily because this will be too hard to type. So if I have sulfur, it can stand alone. We're just going to have some sulfur here because he's not on our list of guys that ends up bonded to itself. And after him I have to put a little S to represent solid. Burns in oxygen gas. Okay, burns in oxygen gas says that I'm putting in oxygen gas. So O2, he has to exist as a diatomic molecule with that 2 after him because he's in that L shape where we determine that. Because it says burns in oxygen gas and it's all before the part that says to form, which is another way to say yield, that all comes before the arrow. Then you have your little arrow here. And we have sulfur dioxide gas. Well, we know that sulfur dioxide is covalent, so it's named using prefixes, and the di tells us we have 2. But I can't forget to put my little parentheses with a G here. Pretty easy. Okay, You all try this one and come back. Pause it, please, and come back when they're ready. Okay, so we have dihydrogen dioxide, 2 hydrogens, 2 oxygens, and it's a liquid. If it decomposes to form water and oxygen gas, that means we're just going to draw a little arrow that goes where it says to form. And we got some water. Now, if you aren't told the state of water, you always assume it's a liquid. If it said steam, we would know it was a gas. If it said ice, we would know it was a solid. So, water and oxygen gas. Put a little G. That's a G. Okay. Pretty easy, right? What type of reaction is this? A plus B yields C. Synthesis. What type of reaction is this? A, B yields A plus B. Well, it tells you right here, decomposition. Good thing to practice. Okay, moving on. Now, in order to balance chemical equations, we have to take the law of conservation of mass into account. And it's pretty easy if you follow a few easy steps. Here we go. The reason we balance equations is because all of the atoms we start with, we must also end up with. A balanced equation has the same amount of atoms on each side. Okay, so if I have 5 oxygens over here, I have to have 5 oxygens over here for my little seesaw to be balanced. It always has to have the same amount on each side. So that's the whole purpose behind balancing an equation, and that's because of that law we talked about, the law of conservation of mass. Cannot be created or destroyed. Alright, let's try it. How are we going to figure out if this equation's balanced? Well, this one's pretty easy. You say I got 1 carbon here and 1 there. They're happy. I got 2 here and 2 there. It's balanced. But they get much more complicated than this. And in order to actually determine it, what you're going to do is I'm going to tell you to do a rep. And what I mean by that is make a little table. R, E, P. Put little lines here. Put a line below it. And we made a rep table. So R, what do you think it stands for? It's these guys on this side of the equation. Reactants. P, what do you think it stands for? These guys on this side of the equation. Products. And the E stands for elements. So I'll say do a rep. First thing you do when you're doing a rep, list out all the elements that are in your equation. So here we've got carbon and oxygen. That's it. Then you go over here and on the reactant side under R, you list out how many of each. So how many carbons do I have? Just 1. And how many oxygens? 2. Same thing on the other side. How many carbons do I have? Just 1. And how many oxygens? 2. Check, and if they're the same, then it's considered to be balanced. Alright, practice makes perfect, so let's do a couple more. That's the same one. I have no idea why I did that. Okay, here are some rules for balancing. If you want to pause it and give them a second to write this down, and then I'll go through and explain them. Okay, rule number 1 is write the correct formulas for the reactants and products. That means if you know that magnesium and chlorine are going together, you have to do what? Cross and drop your charges. So magnesium has an oxidation number of +2. Chlorine has -1. So you're going to end up with MgCl2. That's what I mean by that. And that's why we practiced that all last week when we talked about reaction type. Then you have to count the number of atoms appearing on both sides. In other words, do a rep, like I just showed you on that last slide. And then you balance the atoms one at a time by adding coefficients. Oh, that was horrible. These guys are the numbers out in front. These are not the guys that are the little ones afterwards. Do you remember what they're called? Subscripts. Only change the coefficients. Lastly, double check and make sure it's balanced. When you don't double check and pay attention to detail, it's easy to get them wrong. Okay, here are your nevers. Never, ever, ever, ever do these things. If you want to pause it so they can write this down, that would be great. So, make sure you never change a subscript. Don't do it. Don't change a subscript. If you do it, you're wrong. If you change the formula, it's a different reaction. What if you had H2O and you just decided to add a 2 there? It would turn into hydrogen peroxide. You don't want to drink that, and you don't want to swim in it either. So, never do that. Also, never put a coefficient in the middle. 2 NaCl is okay. Na2Cl is not. You already know this from counting atoms. 2 NaCl would be like having some parentheses and distributing this guy in, just like in math. Okay. Alright, let's do a little practice. Here you go. H2O2. Well, my first step here is to make sure it's written out correctly. Well, it is. It's given to me correctly. Next, I'm going to make my rep table. Whoa. E, P. This board acts crazy, so we're just going to go with that line. What elements do I have participating here? Hydrogen and oxygen. On my reactant side, how many hydrogens? 2. How many oxygens? 2. How many hydrogens on my product side? 2. How many oxygens? Remember, there's an invisible 1 here, so 1. Next thing I want you to do, go draw some blanks right here. This will remind you that the only thing you can change is what's in this blank. There's an invisible 1 hanging out in each of these blanks. So write those in so that you remember, I can only change those. I can't change these. I can only change these. Alright, so I have 2 hydrogens on each side. I don't want to go about fixing that first. I want to look at my oxygens because they're unbalanced. I need to get 2 over here. Well, this is like multiplying. So if you want to, put your parentheses around here and say, what do I need to change this into in order to have 2 oxygens? Well, I can change it into a 2. Distribute it in. Don't forget to change absolutely everything that is affected. It affected my hydrogens. Now I have 4. It affected my oxygen. Now I have 2. Well, that's what I wanted, so that's good. But now my hydrogens are off. That's okay, because it's really easy to go back over here to your reactant side and say, how do I get 4 hydrogen? You're going to cross this one out and make it a 2. 2 times 2 is 4. Hallelujah, they're both balanced. So easy. Alright, now here's an example of when we have multiple of the same compound in separate places, or of the same element rather. We have oxygen here and here. Don't forget to add them all up. Alright, go through, put your lines here, put a 1 in each line. Make your rep table. I only have 1 minute before my recording runs out, so I'm going to go really fast. I got some oxygen, some carbon, some hydrogen. 2 oxygens on the left, 1 carbon, 4 hydrogens. On the right, we got 3 oxygens. 2 plus 1 is 3. Carbon, we got 1. Hydrogen, we have 2. Okay, first things first, I am going to go try to correct my hydrogens. Okay, over here, I'm going to cross this out and make it a 2, and I'm going to end up with 2 times 2 is 4 hydrogens. That's also going to change my amount of oxygens. Now I have 2 oxygens here and 2 here for a total of how many? 4 oxygens. Now my oxygens are not happy, but my carbon's happy and my hydrogen's happy. Go over here, fix my oxygen. Now I have 2 times 2 is 4. Everybody's happy. How did I know to fix this hydrogen first? Well, I looked and I said, if I fix this hydrogen, it's going to affect my oxygen, so there's no point in me going over here to fix my oxygen first. Alright, so take a second here and we'll get the next video pulled up. Thanks for paying attention.